Hi everyone, welcome back to chemistry. In this video, I want to continue our discussion of concentration. Specifically, we want to look at a new way of expressing concentration called molarity. Molarity, we use the symbol capital M for molarity, and it's defined as the number of moles of our solute dissolved per liter of solution. Specifically, liters of solution. So if you're in milliliters for your solution, you want to convert to liters. And also, if you start off in grams for your solute, so say you measure for NaCl is your solute, and you measure 5 grams of NaCl, you can convert to moles in order to get your molarity. And the way you do that is by using the molar mass, right? We know that our molar mass allows us to convert from grams to moles or moles to grams. We've done a lot of practice with that. So that's how you can get to moles if you're not already in moles, if you're in grams. Okay, but let's try this out as an example. So this says a solution contains 3 grams of NaCl and 500 milliliters of water. What is the molarity of the solution? Now, again, as always, I will give you this equation on an equation sheet for an exam, so you don't need to memorize it. But it's such a useful equation that it might be helpful to memorize it. All right, so let's take a look at this. This example says a solution contains 3 grams of NaCl and 500 milliliters of water. What is the molarity of the solution? Okay, so I'm noticing that I have a mass here, 3 grams, and then I have a volume here, 500 milliliters. So liters is going to go on the bottom, but we've got to convert to liters first. And moles is going to go on the top. And we can convert from grams over here to moles using the molar mass. So for our first step, let's just say, let's convert from grams to moles. And we know how to do that, right? That's using the molar mass. So as a side note, we need to get the molar mass of NaCl, right? NaCl is our solute. So let's make a note of that. Water is our solvent. And together they make a solution. Okay, so our molar mass for NaCl is going to give us 58.443 grams per mole is the molar mass of NaCl. And then let me just scooch this up a little bit. Oops. There we go. All right, so let's see. Now we want to convert from grams to moles. So we start with what we're given, which is 3.0 grams of NaCl. And we want to get to moles. So on the bottom, we're going to need grams. So 58.443 grams of NaCl are in 1 mole of NaCl. 0.051 moles of NaCl. Okay, that was step 1. So now we have our moles, which we can plug in here. But we want to convert to liters as well because we're in milliliters. So 500 ml is what we start with. We want to get to liters. We know there's 1,000 milliliters in 1 liter. So we take 500 and we divide it by 1,000, canceling out those milliliter units. And we're left with 0.5. And I'm going to add a couple zeros in there for sig figs. And that is the liters of solution. All right, now we're ready to get our molarity out of this. So step 3, we're going to get our molarity. So molarity equals moles solute over liters solution. So in this case, that's 0.051 moles of NaCl over 0.500 liters of solution. And that's going to equal 0.102 moles per liter. Now, let's take a look at these units here. Notice that molarity equals moles per liter. Those are the units, moles over liters. So we can replace this here, moles per liter, with a big M, because molarity equals moles per liter, right? These two things are equal to each other. So I could replace my moles per liter, which we got from here, as a big capital M. And that's how you'd see it on some kind of solution bottle in lab. You'd see like 0.102 molar solution. And I just kind of said it really fast, but the way that you say this out loud is you would say 0.102 molar NaCl solution. All right, so let's practice this again. So this says a 1.2 molar solution contains 0.50 moles of the solute. What is the volume of the solution? Okay, so now it looks like we've got our molarity and we've got our moles of our solute, and we want to solve for liters. That's what we're solving for, the stuff in green. So let's try this out. So we got moles of solute over liters of solution. This is a lot of times how I will abbreviate this equation here. All right, so we know the left side is 1.2 molar. And then on the right, we have 0.50 moles of our solute over liters of solution, which is what we're solving for. So I'm going to actually replace liters of solution with X, because that's what we're looking for. So replacing that bottom part with X. And let's solve for X. So we need to get X alone, so we're going to have to multiply each side by X. It's going to allow us to cancel that out on the right. And then we get X times 1.2 molar equals 0.50 moles. We're going to have to divide by 1.2 molar on both sides. And get rid of that. And now we have X equals, and let me just show you these units here. 0.50 moles just stays 0.50 moles, but what is 1.2 molar? Well, remember we said that molarity equals moles per liter, right? Moles per liter, that highlighted part right there. Okay, those are the units of molarity. So if we have 1.2 molar, we could also break that up and say we have 1.2 moles per liter down there on the bottom. Now, just as a side note, right? Side note, looking at these units here, if we have 0.50 moles divided by 1.2 moles per liter, we could also think of that as being multiplied by 1 over 1.2 liters per mole, right? Taking the reciprocal of this number here on the bottom. So what happens to those moles? They cancel out, right? And we're left with 0.50 divided by 1.2 liters. Or, just in simpler terms, we're left with liters on the top, which is great because we wanted to end up with a volume, a unit of volume, and we will. Okay, so I'm going to erase my side note here. Right, so those moles are going to cancel out, and I got to get a number out of this. So 0.50 divided by 1.2 is going to give me 0.41. Let's go 42, just rounding for 2 sig figs. So 0.42 liters. And let's replace X with our liters of solution. So the volume of a 1.2 molar solution containing 0.50 moles of our solute is 0.42 liters. Kind of cool. So in this example, we were solving for liters given moles and molarity. In the previous example, we were solving for molarity given moles and liters. But you could also be asked, you could be given the molarity and the liters and be asked to get to moles or even grams, right? If you get to moles of your solute and I want that number in grams, you can get to grams using your molar mass. So what if you are given a mass in grams instead of moles, right? Moles tell you the amount of a substance, okay? So does mass, but they're different units, right? Mass is reported in grams, moles is reported in moles. But if you're given a mass quantity in grams, right, the mass of your solute, you can get to moles of your solute, right? And that is using the molar mass. And then once you get to moles of your solute, well, now we can use our molarity equation, right? Moles over liters. We have to know the number of moles, okay? So you go from grams to moles using the molar mass, and then from moles to molarity using the molarity equation. So just another tool in our tool belt. All right, so let's try this. So a chemist dissolves 1.33 grams of NaCl in 1.5 liters of water. What is the molarity of the solution? All right, well, we're going to need our handy-dandy equation. So molarity equals moles of our solute over liters of our solution. Again, a lot of times I'll abbreviate solution SOLN. Just to recap that. All right, so we're solving for M, big M, molarity. And we know we have 1.33 grams of NaCl and 1.5 liters of water. So I'm looking at the liters of water, and that's good. We have that part of our equation, right? That's already done. We're in liters. But we don't have our moles of our solute. We have our grams of our solute. So again, we need to use the molar mass. Luckily, we got our molar mass up here. So that was 58.443 grams per mole for NaCl. So I'm just going to write that over here. Molar mass, NaCl, equals 58.443 grams per mole. Let me just scoot this down, actually, because we're going to need a little space to convert to moles first. Okay, so step 1, convert grams to moles. So again, we start with 1.33 grams of NaCl. We want to get to moles of NaCl. Actually, I'll show you not using the train tracks this time. We'll use these ones. So we have 58.443 grams of NaCl down here and 1 mole of NaCl. All right, and so that's going to be grams canceling out. And we're going to be left with our moles of NaCl. And I got 0.0228 moles of NaCl. All right, so now we can use our molarity equation. So we can take this number here and plug it in over here. And that's going to give us 0.0228 moles of NaCl over 1.5 liters of H2O. And that's going to give us 0.0152 moles per liter. What is moles per liter? Well, that's molarity. So we'll have molar as our unit. So that's the molarity of this solution. All right, now molarity can actually be expressed as a conversion factor, right? If molarity equals moles per liter, we can use the right side of the equation as a conversion factor, where we have moles of some solute over liters of our solution, or we can flip it, right? So see down here, we've got, if we start with something like liters of solution, and we want to get to moles of our solute, we can use molarity as a conversion factor, where we have liters on the bottom of our fraction, and moles on the top. And that allows us to get to moles of our solute. You can also flip this, right? With any conversion factor, as always, you can flip these. And you can say, well, if I'm in moles and I want to get to liters, I can put liters on top and cancel out my moles, and I'm left with liters. So you can use this as a conversion factor. Big stars next to this because it's very helpful. All right, so this question says you need to make a 0.90 molar solution, potassium chloride solution using water. If you start with exactly 1 liter of water, how many grams of KCl should you add? All right, so note that this solution is made from dissolving potassium chloride in water. So I'm kind of going to be using the term solution and water interchangeably throughout this problem, and that's because the solution is made with water. So we're going to we need our molarity equation, moles per liter equals molarity. And we know, before I do anything, we know that we have a 0.90 molar KCl solution. So let's break this down for a little bit. So if molarity equals moles per liter, then we can replace that M, big M, with moles per liter. Now, if our solution is 0.90 moles per liter, just like when I say miles per hour, and that's assumed, if you're going 65 miles per hour, that means you're going 65 miles in 1 hour. 1 hour, right? Same idea here. There's an imaginary 1 right here for liters, right? Miles per hour is not miles per 2 hours, it's miles per 1 hour. So this is the same idea. 0.90 moles per liter can also be written 0.90 moles per 1 liter. Moles of what? KCl. Liters of what? Solution. Right? That's our molarity. And now what's really cool about this, and I haven't really done anything, I'm just expressing this number in a different way, right? This is the same thing. These equal each other, which also equals this, right? Those are all saying the same thing, just in a different way. Anyway, so this can be written, it's our conversion factor. That is our conversion factor. And this is how we can use molarity as a conversion factor. Okay, so, and let's color code this as yellow again. All right, so we know a conversion factor that's going to help us out. We start with what we're given, which is 1.0 liters. I'm going to say solution, just to simplify things, because we know this solution is made by dissolving KCl in water. All right, so we start with 1 liter, and we have a conversion factor. Now, we want to get rid of that liter and end up with moles in order to eventually get to grams, right? Okay, so we've got 1 liter of solution on the top, and we need liters of solution on the bottom, specifically 1 liter of solution, because I'm using this as my conversion factor. And then what goes on the top is 0.90 moles of KCl. All right, now I'm done with liters of solution. Okay, those cancel out the units. And then I'm left with moles of KCl as my unit. Now, I didn't want moles of KCl, I wanted grams of KCl, but we're definitely closer, right? We were in liters of solution, and now we're in moles of our solute, KCl. How do we get from moles of KCl to grams of KCl? Molar mass of KCl, right? Okay, so side note, molar mass of KCl. All right, so I did the math off camera, so to save us a little bit of time, and I got that the molar mass of potassium chloride is 74.551 grams per mole. All right, so if it's 74.551 grams per 1 mole, we can put 1 mole of KCl on the bottom. We're pretty used to this now, right? And 74.551 grams of KCl on the top. Now I can cancel out those moles of KCl, our units, and we're left with grams of KCl, which is great because that was our goal. Okay, now let's get a number out of this. So we got 1 times 0.90 times 74.551. And that's going to give us 67.1. Actually, let's leave it at 67 because we only have 2 sig figs. So I have to put 67 grams of potassium chloride in 1 liter of water in order to make a 0.90 molar KCl solution. And this is what chemists do. We do this math in order to figure out, hey, if I know I need this concentration for my solution, I need to figure out how much I need to dissolve in water in order to get that concentration or that molarity. All right, so just like we saw above, we can use molarity as a conversion factor to convert between lots of different types of units. We can also use molarity in stoichiometry problems. Remember, stoichiometry means using a balanced chemical equation to convert between moles or grams of one thing to moles or grams of a completely different substance. As long as we have a balanced chemical equation that relates those substances. So say we wanted to know how many liters of aqueous hydrochloric acid solution, right? Hydrochloric acid dissolved in water, that's just what aqueous means. Say we wanted to know how many liters of HCl will react with a given mass of NaOH, sodium hydroxide. We could use this approach on the right to get from, one to the other. So if we started with the mass of our sodium hydroxide, which we could measure out in lab, we've worked with sodium hydroxide before, it's a common base. So we can get a mass of that, that's our known quantity. We can get to moles of NaOH using the molar mass, right? We know how to get from grams to moles of one thing using our molar mass. Then we can get from moles of our NaOH to moles of HCl using what? Balanced chemical equation, right? That relates HCl to NaOH, right? 1 mole of HCl goes in and 1 mole of NaOH goes in, right? Now we're in moles of HCl and we can get to volume of HCl using our molarity equation. So let's try this out. So this example says, how many milliliters of a 2.75 molar HCl solution are needed to react with 185 grams of NaOH? Okay, so we want to get to milliliters from grams using molarity as our conversion factor. So let's write some of this down. So we want to get from grams of NaOH to milliliters of HCl. Now, we know how to get from grams to moles of NaOH. That's using our molar mass of NaOH. We also know how to get from moles of NaOH to moles of HCl using our chemical equation or mole ratio. And now we've just learned how to get from moles to milliliters or liters, right? A unit of volume using what? Yeah, molarity, right? Molarity, because that equals moles per liter, right? Okay, so I know this is a lot. Let's try this out. So we are in grams of NaOH. So we're over here, right? We have this many grams of NaOH. So we want to get from grams of NaOH to, what's our next step? Yeah, we want to get to moles of NaOH. Let's color code that. We'll make it blue. So we want to get to moles of NaOH from yellow to blue. So we need our molar mass of NaOH. So let's go over to the side here and get our molar mass of NaOH. All right, I did the math off camera, so that's 39.998 grams per mole. So 39.998 grams goes on the bottom. Right, we want to cancel it out. 1 mole goes on the top. Cancel those things out, grams of NaOH, and we need to multiply next by another step. Okay, so now we're in the blue, and we want to get to, let's go green, moles of HCl. So how do we get from moles of NaOH to moles of HCl? Yeah, we got to use this balanced chemical equation, where it says 1 mole of NaOH reacts with 1 mole of HCl. So in this particular problem, even if you left this step out, you'd probably get the answer right, and that's great. But if you had any other ratios, say it was a 2-to-3 ratio, that's what will go here. So it's great in this particular problem that you would still get it right if you messed up, but that's not always going to be the case. So remember, you always, 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 when you're converting from moles of one thing to moles of a completely different substance, there is no way to do that without your balanced chemical equation. Okay, so I'm definitely going to be looking for that on an exam. Okay, now we're in moles of HCl, and we want to get to, what do we want to get to? Liters of HCl. Well, we want to get to milliliters of HCl, okay, but we don't have even liters. So let's get to liters first, because we know our molarity is expressed in moles per liter. And specifically, sorry, let's put moles of solute over liters of solution. Okay, so we know our molarity, right? And I'm going to jump to yellow for this one. So we know our molarity is 2.75 molar HCl. And remember, we can write that big M as moles per liter. So the conversion factor we can write from this is 2.75 moles of HCl, our solute, over 1 liter of solution, right? This, moles and liters, is molarity, right? That's the same thing. Okay, getting kind of messy here, but that's okay. So we can use this as a conversion factor over here. Whoops, over here. So let's do that. So we got 2.75 moles of HCl in 1 liter of solution. And that's great. That would give us liters of solution. But we also want to get to mils. So I'm actually going to do that in our next step. So let's just get a number out of here. That's going to give me 1.68 liters of solution. And we want to get to milliliters. Milliliters. So that's going to be 1680 milliliters of solution.